Okay, in this video I'm going to introduce macros. Now macros may seem similar to inline functions, but there are quite a few important differences. We'll talk about those differences in a bit more detail later. A macro is a user-defined identifier that represents or is associated with an expression or a statement. Now once defined, that identifier or macro can be used as needed. You can use it many times in your file, so as needed. The preprocessor is what expands the macros. The identifier is basically replaced by the expression or the statement, and we use the define directive to define a macro. You will use that define directive followed by the macro name, followed by the associated constant, statement, or expression. The final line on the slide shows you an example of a macro called end, and in this example it's a statement, a console output, and it's going to print out end of program. A quick example in Visual Studio, I define this macro right here called end, and I use the statement right here, console output, end of program, end line, and it's a statement again because I end it off with a semicolon. In main I have a few statements for demonstration purposes that will simply print out 5 to the console, and then with this end macro right here you can see how I call it. That should now also print out end of program. Following the printout of 5 we have a new line, then we have another new line, and then we have this end of program printout. Now what happens if I remove this semicolon? This line right here will now expand to an expression and not a statement. Okay, so we are going to miss a semicolon. You can end it off with a semicolon and that will work fine. This is a bit weird, so that is why you may want to add the semicolon in the definition of your macro, but it's really going to depend on what you want to do. You can also simply have values in your macro definitions. Something like this. It may not be very useful, but you can do that. Before they introduced null pointer, we used to have this null macro, and if not already defined, you would typically define this yourself. The IntelliSense shows us what this expands to. It expands to 0, and you can see the define right there, define the name, which is null, and the associated value, which in this case is 0. You can also write null, just the value 0. In modern C++, you want to use the null pointer keyword, but I just wanted to mention the null macro because you may come across that in older code, or come across it in older tutorials or books as well. And this is basically what happens. We get simple substitution. The macro identifier 3 in the console output statement is substituted for the value 3. We can also define macros that accept arguments. You use the _define preprocessor directive as before, followed by the macro name, and then between parentheses you have a comma separated identifier list, followed by the statement or expression that uses those identifiers. Now I call these identifiers because they are not really parameters, so you're not really passing by value or passing by reference or something like that. Again, when it comes to macros, we are doing simple substitution. As a quick example, in Visual Studio I have this macro called square. It has this x as an identifier, and it simply does x times x, so x multiplied by x. And in main I do console output square and I pass in 3. You can see this is similar to a function call. I'll build and run this, and this should print out 9. Prints out 9. This is a basic example. It's gonna get a bit more complex here in a second, so let's just look at how this is substituted in a slide and then we'll come back. This is what the substitution will look like. Anywhere you use that macro name and you pass in an argument, so for example we do square and between parentheses we pass in 3 as in the previous example. The definition is x times x, so the substitution is going to be 3 times 3 with that argument of 3, and that gives us 9. This evaluates fine if we pass in a single value such as 3, but if we do something like 3 plus 2, we would expect to get a printout of 25. But if I build and run this, you'll see we get 11. Let's go and look at how this evaluates to see why we get this value printed out. Let's look at the substitution. We do square 3 plus 2, and this is going to be simple substitution. It does not evaluate 3 plus 2 and then pass 5 in as an argument as we are used to. So the substitution again is x times x. Whatever you pass in between parentheses is going to be the substitution. So we're going to do 3 plus 2 times 3 plus 2. That is going to give us 3 plus 6 plus 2, and that is going to give us 11. So maybe you can pause the video for a second and think about how we can fix this problem. So if you thought about using parentheses, then you are correct. Okay, so we can do something like this in the definition. And if you build and run, you get 25 as you would expect. And the parentheses work, so let's look at the substitution. We do square 3 plus 2. In the definition, we have x between parentheses multiplied by x between parentheses. So this is going to give us 3 plus 2 between parentheses multiplied by 3 plus 2 again between parentheses. That is going to give us 5 times 5, which will equal 25. So the expression that you pass in as an argument does not get evaluated. Then the result passed in as an argument, as we are familiar with functions. So we can work our way around that using parentheses. Now there's one more problem with this. Let's say I do. So I'll do 18 divided by square of 3. What we would expect from this result is 2. But if I build a run, we get 18. This is how it's going to evaluate. We're going to do 18 divided by 3 times 3. It's not going to do 3 times 3 first as we would expect. It's going to do 18 divided by 3 first, and then it's going to multiply that result, which is going to be 6, with 3, and that is going to equal 18. We can also solve this problem using parentheses. Build and run, we get 2 as we would expect. Before we move on, I'd like to note that if you put a space right here between the name of the macro, so the macro identifier, and the identifier or the list of identifiers between parentheses, then this won't work, you'll get an error. You can think for a second why that would be. It says x is undeclared identifier. So this is now kind of part of the definition, right? But it doesn't know what x is, and that is why x is undefined. This is not like a function where you can have a space right here. So it's going to do 3 times 3 first, right? And that's going to give us 9. And then we are going to do the division. So we're going to do 18 divided by 9, and that is going to give us 2, which gives us the result that we would expect. In this example, I have this my macro identifier, this macro, and if I try and redefine this, I'll get a redefinition warning. So basically I have a conflict, alright? So what you can do is you can undefine or remove the definition of a macro, and you can do that using the undef directive. So all you do is you use pound and then undef, okay, to undefine, and then the identifier, so in this case my macro, and this will allow us to redefine that macro. You can see right here, if I hover over this, you'll see identifier my macro is undefined. And now I can redefine that if I want. Okay, so that is a quick look at using the undef directive to remove the definition of a macro. As I mentioned, your macros can accept multiple arguments. So in this case, I have a comma separated list. So I have two identifiers, in this case x and y, and I'm simply multiplying them together. The name or the identifier of the macro is a multiply. Alright, so I pass into arguments 3 and 5. Build and run and we get 15. So what's really nice about this thing is we don't have to write overloaded functions. Let's say we want to do a multiply function. We don't have to overload that function to accept integers and floats and so on. We can simply use this macro. So now I'm passing in 3.5 and 5.6. And that works as you would expect. Now I'm just sharing this because you might come across it in other people's code, and in some situations you might find it handy, but I would recommend that you avoid using macros with arguments and instead use inline functions, because with inline functions you get type safety as with regular functions. A brief summary on macros versus inline functions. Substitution for macros are handled by the preprocessor. Okay, so we get simple substitution. The preprocessor is basically like a text file that gets sent off to the compiler. Substitution for inline functions are handled by the compiler. Now that means we get type safety because the compiler performs type checking, and thus inline functions provide us with type safety. Also, the expression supplied as an argument is evaluated before the body of the function is executed. Right, so let's say you pass in an argument of x plus 1. It's going to evaluate that and then pass the result as an argument to the function. whereas again with a macro we do simple substitution. So the rule of thumb is to use inline functions instead of macros. There are some predefined macros as we've seen with the null macro for example, and those are provided for backward compatibility. So macros can be useful, you'll see them all over the place in Unreal Engine, and when you develop in Qt you'll also come across a few macros, but again try and use inline functions instead. Alright, that is going to wrap up this lecture, I'll see you next time.